Okay, so we have another problem. So there is a force that's being applied with an angle of 30 degrees with vertical, and this shape here has a length of 0.4 meters and then height of 0.2 meters. The question is that, as in before, what is the moment about point O? Okay, so we need to find the moment about point O. But chapter 3 is all about the moments, but each time we use a different formulation. Okay, sometimes we use a scalar form, sometimes the vector form, sometimes we change the axis. Okay, so let's start it. So I need to find the arm of this vector force. Okay, so to find it, first I need to know that the moment is R cross the force. Okay, the R is the position vector, and then the force is just the force that we know. So I have the R here from that point to this point, so this will be the R and then I need to find the cross product between this R and that F. Let's do that. So to find the R, so I need to move from point O to this one. Okay, so I can define this will be my y-axis and this will be my x-axis. So to move from point O to that point, I will go 0.2 steps down and 0.4 steps to the right. So let me call this point as B, okay? Okay, so 0.2 steps down. It means that negative 0.2j, okay, and 0.4 steps right. That will be 0.4i. Okay. Then, in that case, the position vector will be that 0.4i minus 0.2j. This is okay, and then next comes the force vector. I know the magnitude, but I don't know the components. So it means that I need to find the force as a x component and then y component. Okay. But I know that the force is this way. It makes an angle of 30 degrees, so it means they will have f of y and f of x, and that will be 30 degrees, and this one is 90 degrees. Okay, f of y is f cosine 30, f of x is f sine 30. Okay, f cosine 30 is 400 times cosine 30, and then 400 times sine 30. So that will be that 400 times 1/2, 200 newtons. Okay, this one will be that 400 times 0.866. Okay, that will be the y component of the force. Okay, let me calculate it. This one will be 346 newtons. Okay, but I know that this is positive because it's in the x-axis, but this is negative because it's in negative y-axis. So then force will be negative y-axis, positive x-axis, 200I minus 346J. Okay. That will be the force. The time is to find the cross product between this force and this arm. Okay, so I will do it here. So first let me erase this part. Okay, cross product will be that we have the I component, then the J, and then the K. So we have the position vector, which is 0.4, negative 0.2, and then 0. We have the force, which is 200, and negative 346, and then 0. Okay, so we need to find this determinant. So first, the I component, this one, means that erase this part and then erase that part, so it will be this one times that one and this one times that one. So it will be that I component will be negative 0.2 times 0 minus 346, that's negative, times 0, so that will be 0. Okay, so the final moment, it doesn't have the I component, so that will be 0I plus or minus, we will see, and then becomes the G component, the J component. Similarly, it's a J, so we will erase this part, we will erase that part, because if you do that, so you'll have 0.4 times 0 minus 200 times 0, so this one will have additional negative adjustment, so it will again be 0. Okay, so it will be 0I and 0J. The finally is the K component. Okay. For the K component, the similar logic, similar principle, erase and erase, so you'll have this one times that one, so it will be 0.4 times negative 346 and then minus 0.2 times 200, so it will be that 200 times negative 0.2. Okay, so let me calculate it. Okay, and this one makes negative 99 Newton meters. Okay, so it will be negative 99. Okay, so the final result is negative. So what it means is that the force rotates in clockwise direction. Okay, so this way. Okay, so this is the vector form of the moment calculation. But you can do in scalar form as well. So I will do in the next method. So you will see that we are getting the same answer. Okay, so now let's use the second method, which is the method that we know. So in the previous recording, we have found that this will be Fy, that is 346, and that's f of x, that is 200. Okay. And then we are looking about point O. But as I can see here, f of y will create a moment this way. F of x will create a moment that way. Okay. And this f of y about point O will have an arm of this much. F of x about point O will have an arm of this much. So I have drawn f of x here, but you can do it here as well. So that's the same f of x. Okay, same. So in that case, I will have the moment due to f of y. Okay, that will be 346 times the arm, which is 0.2. Okay, and this one is a clockwise moment, that is negative. And then moment due to f of x. And this one will rotate, you see, it will rotate that way, which is counterclockwise. So that will be 200 times the arm of it, which is 0. So this one is 0.4. Sorry, this one is 0.4. So f of y will have an arm of 0.4. F of x will have an arm of 0.2. Okay. And this one is a counterclockwise, and that is positive. Okay, so then if I can find the resultant moment, that will be negative 346 times 0.4 plus 200 times 0.2. This one is positive counterclockwise, negative clockwise. Again, it becomes negative 99. Okay, you see, we get the same answer. So this one and that one gives the same answer. It should, because these are two different methods. So this one is useful for 3D problems. Okay. Otherwise, this is a complex one. This one is the simple one. Okay, thank you.